A cubesat is not much larger than a loaf of bread, but provides a compact orbiting home for a host of sensors and instruments. Scientific breakthroughs over the past decade have made it possible to build cheaper and lighter satellites that can still hold all of the equipment of much larger spacecraft, communications, navigation, and power generators, along with a payload for their assigned task. The Applied Physics Lab has sent 2 cubesats into orbit, and they are proving to be so versatile that more launches are already planned. Bill Schwartz is the leading scientist of a project called Raven that will use cubesats to better predict the Earth's changing climate.
This would be used to measure what scientists believe to be a small imbalance between the incoming solar and outgoing reflected and emitted radiation from the Earth that will drive future climate.
Schwartz says the main sensor, called the radiometer, will be built from one of the blackest materials known, carbon nanotubes.
One of the nice things about this technology is it's very black, and if we're trying to measure the radiation being emitted or reflected from the Earth, we want a very, very black substance.
The first Raven CubeSat will be launched next year to see how the nanotube device works.
So hopefully within the next couple of years we will have raised the so-called technical readiness level of the carbon nanotube absorber that's used in the spacecraft and some other key elements of that technology, and that would then be available for a future mission.
The first satellite will be positioned between 550 and 750 kilometers above the Earth, allowing it to monitor the entire planet. Later, a whole constellation of 30 to 40 CubeSats will simultaneously register the radiation from all points of Earth, dayside and nightside, helping to answer the question that affects us all. What is the long-time future of our planet's climate? George Putic, VOA News, Washington.